So next on my list, let's see what I dive in and talk about evaluating trigonometric integrals. That is to say, integrals that involve factors, or excuse me, combination of trigonometric expressions in the integrand position. Let me start off with the case for which I may have a combination of sines and or cosines in the integrand position, where at least one of them is being raised to an odd power. My approach? I'm going to shave off one factor of the sine of x and cosine of x, whichever one's raised to the odd power, that's cosine of x in this example, and convert the remaining even number of them in terms of the other function, in this case sine of x, using my first Pythagorean identity. Let me illustrate. As I suggested, since the cosine of x is being raised to an odd power, I'll shave off one factor. Notice how the remaining factors of cosine of x are raised to an even power. And I'm going to convert the remaining number of cosine factors into sine expressions using my first Pythagorean identity. So let me do just that. Notice what's being squared here is the cosine squared of x, which can now be interpreted as 1 minus sine squared of x, as I suggested by the first Pythagorean identity. Now I'll commit to a u sum. I'll allow u to be equal to sine of x because its derivative is a factor in the integrand position. Now committing. Of course, that's going to be an absolute piece of cake, isn't it? I will expand, distribute. Now I just have a polynomial expression in the integrand's position in terms of u, anti-differentiate term by term using the power rule for anti-differentiation, and merely back substitute. I'll leave that for you.